Good afternoon, everyone. I think most who are in the lobby are now in the meeting. And just to introduce today's Masterclass webinar subject, Effective Continuous Monitoring of Track and Rolling Stock Performance, Freight Reliability and Passenger Comfort. And before I introduce the presenters, I'd just like to acknowledge the traditional owners of the lands where we meet today. And for me in Brisbane today, that's the Turrbal people, and to pay my respects to elders past and present, and I extend that respect to Aboriginal and Torres Strait Islander people who might be with us today. So today we've got Stephen Tsang, Technical Principal at Interface Rail Engineering, and Dr. Mani Entazami, Research Fellow at the University of Birmingham and Chief Technology Officer at Monorail. And thank you, Mani, in particular. It's just turned 7 a.m. over in bright, sunny Birmingham, as I understand it. A bit of background on Stephen, firstly. He's had 23 years of rail experience that includes design, construction and maintenance of rail infrastructure. He's worked in the Victorian rail industry for 5 years, representing rail operators and providing subject matter expert input into track and civil disciplines. Projects he has been involved with include level crossing removals, Metro Tunnel Project and Melbourne Airport Rail. And a highlight from Stephen's career includes a tenure as the track and civil lead for Suburban Rail Loop, where he was part of the Technical Advisor Consortium. At that time, he was the Technical Director for Track and Civil. And a bit of background on Mani before we start. As I mentioned, he's a Research Fellow at the University of Birmingham, which is a Railway Research and Education Centre. Mani has more than 12 years experience in research and engineering, including 8 years in condition monitoring, system modelling and signal processing. Mani's PhD work was based on novel condition monitoring techniques for wind turbine brake systems. And he is currently working on trackside and onboard monitoring system design for rolling stock and infrastructure. So before I hand over firstly to Stephen, just a reminder for those online that you can enter any questions you might have into the Teams chat at any time. And then at the end of the presentation, we can provide them to Stephen and Mani to provide their answers. So without any further delay, I'll hand over to you, Stephen.
Okay. Yeah, sorry about this. So just give you a bit of background who we are and where we're coming from. So we are part of UCRIN, which is a UK Rail Research and Innovation Network in the UK. Is a £90 million project that UK government and industry funded. We are the Centre of Excellence for digital systems at the University of Birmingham, and we work with our colleagues in Huddersfield and Southampton, which they work on a rolling stock and track. And the idea of UCRIN is about to basically bring in research and innovation into more commercial products and developing that with the industry very closely. So this is just our innovation journey. So it started from a university research with very low TRL, started getting funding from different funders like EPSRC, one of the engineering councils in the UK, and building equipment, doing the analysis, finding the right algorithms, doing the mathematical model around them, and again, pushing through higher TRLs based on the background that we have at the School of Engineering within the university, and finally doing some feasibility study with industry and understanding the market and knowing where the gaps are, and finally forming a company called Monorail with the UK in basically Innovate UK, which is a UK government funding, and also industry partner Unipart Rail. And finally, we started operating as a company, which I'm the CTO, and we have managed so far to win quite a lot of awards in the UK, have lots of contracts with different companies, including Network Rail in the UK, Eurostars, Eurotunnel, and also now we're working with Americans, a company called MXV Rail in America. So just the challenges. So one of the key points that that we want to help Network Rail, for example, in the UK, is around delays and cancellations. One of the issues with the cancellations and delays is about track faults. I think Stephen is back. Do you want me to pass on to Stephen, because he's got some?
Can you hear me now?
Visualize it much better. Yes.
Yes. Sorry about that. It just jumped to some. I have no idea why. But apologies. Let me share again. Okay. Can you see that?
Yeah, that's better. Thank you. Yeah. So if you want to go to the next page.
Next page. Okay. This one?
So yeah.
Okay.
Yeah, that's the one.
So sorry about technical issues there, but Manny was filling in very well. So these are the, I think for me personally, it's the journey and the true research strength behind these systems that caught my attention, and as a studying at University of Birmingham as well. So the systems are very appreciated by, as you can see, some very well-known names. People who are currently partners and customers with the university for this system. Challenges and motivation. So I guess I didn't hear the first part, but there are many challenges, and then on the railway industry and the operations and all that go around it, and a lot of efforts made to make network systems run very well. So what challenges do we normally face? So there's delays and cancellations, which is a big operational impact on reputational. Maintenance effectiveness. So basically how long the maintenance effort lasts. And you can see that I shan't go and dwell into the numbers, but it has a big impact on the cost of keeping the asset in good condition. Reliability and performance. So these are the key metrics that operators and various by passenger or freight that measure how effective they are, and also passenger comfort. So this is becoming more of an issue as the track gets better in many countries. The next level is to have a decent passenger comfort. And if we can look at this video, can you hear the sound? No,
don't worry about it, but
okay.
You can see from the vibrations.
Yeah.
So just to point out, this is a line between Gatwick and basically Brighton, and it is only one train that makes quite a lot of vibration and discomfort for the passengers, but the rest of the other type of classes, they're running quite perfectly and smoothly on that track. And one of the issues we've got in the UK is that if the driver reports a problem like rough ride, the Network Rail has to impose some speed restrictions, and that could cause quite a lot of delay minutes and cost. And as you can see, one of the figures, we had about 99 driver reporting rough rides in 1 year, which caused about 50,000, nearly 50,000 total delay minutes, and costing about 7 million.
Okay, I'll turn the audio on. So actual problems. So I guess these systems, the condition of the asset causes issues, and the following issues that are common: speed restrictions, mostly from track faults. So through a section here, it's trying to depict that you have to slow down for a set distance where a known fault is, and that causes delays, and then it mounts to punctuality issues, and then possibly financial penalties for not meeting service requirements. Unplanned maintenance, things such as broken rail, which obviously unplanned. Also to do with understanding the condition of the assets. Wheel rail interaction. So this is important in many aspects in terms of what it's doing to the track, what it's doing to the rolling stock wheels, and that sometimes the lack of understanding can cause problems and delays in fixing the root cause, and not actually, sometimes they don't fix the root cause, but they fix something that's a symptom of the cause. And I think the main issue is separating between train or track specific issues. Normally it's, I guess, one blames the other, even in the same organization. So it's important to know if it's a track issue or a train issue, so that the faults can be fixed quickly. And here's obviously a graph I think we all know. If we have a low repair, sorry, if I move this, can I move this? Yeah. Preventative maintenance. So preventive, you have to spend a lot of money up front, and then you get good asset life, but the capital cost is sometimes prohibitive. Or you can have reactive maintenance when you don't do much, and then obviously as the faults come, you spend more and more money. I guess the happy medium, what most organizations strive for, is to have an optimum, then yeah, which is the overall least cost. Okay, there's some preamble. I think it's worth spending time to understand the history and what's existing and how useful I think this system is from Monorail. So existing measurement systems, I think we all know this, the Dr. Yellow, and then there's the NMT for Network Rail, and then there's New South Wales measurement train. So these are expensive items, but saying this, I think legislation requires the operators to, these are safety critical, so they require recordings periodically for the operator or the asset owner to prove that the track is in a safe condition. Unfortunately, the points I probably need to make is they don't behave the same as a passenger train. I'll come to that later, and it's, as well as the huge capital cost, there's a huge maintenance cost associated with it, and it doesn't cover the whole of the network. Which brings us on to, I guess, this is the system that UOB developed. It's not a replacement, it can't be, but it's supplementary or complementary to the systems that are performed by these. And these are relatively cost-effective pieces of equipment, so accelerometers, inertial measuring systems. So briefly, that you can mount them on primary suspension, secondary suspension, and axle boxes. And this is a brief. These are the sensors, and this is the data system that goes through, and then it comes into a main user interface, and the end user can use it. I'll just gloss over this, but it can be mounted. It's can be tailored to each rolling stock type. It can be mounted on various places, and UOB would advise where to mount it so it's safe and doesn't interfere with existing systems. And I'll let you peruse this when you get a copy of the slides. And finally, the user interface. So this is completely customizable. By the way, I'm not trying to sell this as an engineer. I think this is it's interesting at what they can do for a fraction of the cost of existing systems. So this is Deutsche Bahn interface, Unipart Rail, which is a partner of Monorail, and this is the core data. That's the user interface at the core when there's nothing there, and all the data is just very raw and not processed. So before I carry on, I think the power of the system comes in, not as collectively, individually, it's probably not innovative, but the whole system performs, I think, in a very innovative way when you get the data, and data, when you analyze, you can glean so much out of it. So examples I will go on to here. Rough ride report. So yeah, when a driver goes over and feels a bump, they report it, and often than not, they get it wrong. So there's you can see this line, driver rough ride report, and that no cause found, because where the driver thought it was, he's like, I don't know, hundreds of meters or tens of meters down the track, whereas the actual system itself can pick up through its analysis. You can see that the rough ride is here, where the actual report was here. So it's basically wasted reaction force going out, finding no fault, and then yeah, that's time wasted and problem not solved. And from the graph here, you can see that mostly the drivers are 100 to 150 meters out when they report a rough ride. So that's one of the things that can do to pinpoint in real time. Oh, this one's an interesting one. This one's somewhere in Scotland. So you can see the two traces of different classes of rolling stock, the class 170 and class 158. And various traces, interestingly, it's going through on the same piece of track, but two different trains. And that you can see that the vertical ride quality here for the blue one, which is 170, is worse, much worse than the 158. Now, class 158. And you can see that the class 170, the red means it's severely bad ride, and the black for the 158 is only spots are severely black, which basically means you can see it's related to the suspension types for each rolling stock. So the power of the analysis can actually tell you even with the same route, different trains behave very differently, and it picks it up. So the main reason for it is the class 70 has these chevron type suspension, whereas the class 158 is there's a more recognizable steel coil suspension systems, which are I guess more compliant. So that's the type of analysis you can get from this system. I'll pass on to Manny, who's more expert than me at these these lots of graphs. So Manny, please.
So we're working with UK network rail high speed, and one of the issues that have in the UK where they don't actually measure the long wavelength track geometry, which can affect poor ride quality. So if you can see on the bottom right figure, you can see every time the blue curve has an increase, that the red curve, which is the ride quality, also increases, and that shows how correlated the long wavelength track geometry compared to ride quality. And this is something that is quite important to see the train and track interaction. So on the left, you can see there are certain areas which you can see 35 meter, 70 meter and 140 meter wavelength issues. That is quite common. But on the red area highlighted, you can see not much problem around the 35 or 70, but you can see quite a lot of issues around 140 meter wavelengths, which in the UK, for example, Network Rail doesn't have that information from the measurement train. And for a train that goes over 200 kilometers an hour, these informations are quite vital to understand and bringing passenger comfort and safety for the basically track operators and train operators.
Okay, thank you for that. This one I understand a bit more. So basically, this is a particular area. I forget where it was, but you can see that in the blue, these are the traces for the measuring train. This one needs renewal, obviously because of the high displacements. So after renewal, it looks all good. So that's the renewal section. You can see that the red is the IMU measurement, and you can see there's far less displacement, which signifies that the renewal has been successful. But the only issue is that the run time of these measurement trains can be 1 month, 2 months, depending on the track section. However, with the IMU, immediately you can pick up. So here, it's actually picked up that there's a transition, well, there's a big displacement here, big spike, despite it's being renewed, and it's associated with there's a level crossing there. So maybe the interface hasn't been actually renewed properly at that section. So this picks it up immediately instead of waiting 1 month, 2 months for the problem to be fixed. And during all that time, there could be a speed restriction on that. Okay, so over to you, Manny, please, to the
so one one of the key areas that we do in terms of analysis. So we bring in different sort of parameters and do different sort of analysis on the data, depending on the need of the customer, and also to identify the root cause. So on the left, you can see that we more or less put in all the results from the EN standards, which is for the rolling stock instability checks, which we have in Europe, and it's got about over 3,000 train runs and picked up the maximum values for that specific standard threshold. And you can see around a certain time of the year, around certain area on the track, you can see quite a lot of red points on that area. And if you look at the bottom graph, you can see that those red points, which is now in a 2D dimension, is basically against distance. So you can see that all more or less happening in two specific locations rather than across the whole network. So it shows the train might be running fine, but there is a real rail interface issue where after certain wears, after certain type of wear, then your body starts becoming unstable, and that exceeds the threshold. And you can see how the maintenance and having a good regime of maintenance can suddenly reduce that sort of vibration levels and bring it into normal behavior, which you can see on the right hand side figure, that after the maintenance and different type of maintenance, you can see two different steps that changed. It just shows how different maintenance can affect these sort of vibration levels, and how we can identify areas on the track that could cause instability along the train, which has some worn wheels. So in a way, it is a bit of a both, and looking at it as a complex system and making sure that the rolling stocks and the infrastructure are working together to identify and address these issues. So this is again another example of how we can look at these data in the long term. So you can see at the start from July, it is the vibration levels started going high, some maintenance happened, and then we also decided to make some changes, induce some faults, and seeing how these faults can basically affect the running and safety. And you can see by changing slightly in the wheel profiles, we managed actually making body of the train hunt more than the, well, not hunt, but vibrate more than the bogie. And you can see the body and the bogie vibration levels more or less have gone into similar sort of performance. So this is again another way that we can analyze the data. So if you have a specific rolling stock, you want to run it on a specific part of the track, you want to change your speed. For example, you want to run at 100 km/h, you want to run at 140, depending on your needs on the basically network. Here we have analyzed different sort of speed profiles, working with the operators and the infrastructure people, and seen that how the wear of the wheel sets and the wear of the suspension can affect the ride quality, and also the vibrations and instability on the body and the bogie compared to the maintenance regimes. So you can see around August that things have changed, and you can see the black dots are basically when the train's going over 130 km/h, and the blue dots are when the train's going around 100 km/h. So you can see after the maintenance, those sort of levels of vibration are more or less the same, showing that a good maintenance can help you improving your speed, and having the right profiles of the wheels can actually help you going faster in certain parts of the track if the track geometry does allow you that. And again, you can see the very specific wear that happening over time as well. So for example, on the body, you can see the red dots are growing over time. So this is a linear wear that you can see caused by basically wheel wear and the mileage that goes on the train.
Oh,
yeah, that's it.
Yep.
And again, this is a simplified figure, so you can see from November to December how slightly things change, but you can see those wears, and having this information can help you predicting when it's going to be in stable position. When can we do the wheel profiles? Do we need to do sooner? Can we push it further? And basically do a predictive maintenance and make sure that all maintenance are optimized. So this is another use of our data. So it's just the data from the wheel from the wheels, and you can see there's a significant change between the profiled wheel and the wheel data from the day before being profiled. Both of these data sets are coming from one of the high-speed networks in the UK, and you can see the spectrogram where you have the frequency and the time analysis all at the same time. You can see there are certain areas that are quite significantly shown in the both spectrums, and some of these are being basically influenced by the wheel wear, and some of this could be track related. But if you have a brand new wheel profile, then you can actually use that as a sensor and identify corrugations on the rail. So there you go. So this is one of the areas that we managed to identify corrugation by knowing that the wheels are in a correct shape, and how we can process data to get to that point that we can identify these type of track related issues as well. So now, just later on. So this is an example of field grade interface that we've done. So we did some thermal imaging and vibration, and I put the vibration data into sound and mix it with the video so you can actually see how it interacts. And this is just an example of how we can use the data to understand the wheel grade interaction and different type of track and how they can interact with the wheels. So for example, ballasted track has a different behavior essences when it goes to, again, different behaviors. But again, all of these just very simple information which we can do more analysis on them and gain more knowledge out of this.
Okay, thanks for that very haunting sound, I think. Okay, so all this data, so these traces you can see are an iron standing on the same route, various different rolling stock and various dates, and you can see that the repeatability of the data is within 10%, and it's highly repeatable. So the quality of data is good, and consistency for many applications is also important. So this is a demonstration of all different systems, but they are very repeatable. And then this is, I guess, the ultimate test, a comparison to a proper train, tens of millions of dollars worth of machinery. See, what's this? The green one is the IMU, and the recording coach is the black one. And you can see it correlates very, very well. Bar the cat deficiency, all the rest, the correlation is very high, which gives confidence that this is measuring as much in terms of quality. But bear in mind that this has limited capability in terms of things like track gauge are not recorded in this. These are inertial systems, accelerometers and the like. So, but that's not to say it can't be done in future, Manny. And a summary, of course, basically for myself, this is a complementary or supplementary system. It's cost effective in real time, and the data quality and analysis you can do with is very, very powerful. And I guess that's the quick summary. You can read this for yourself, but for me, I think this operators around the world should take note and of this cost-effective maintenance tool. Many questions? Thank you all for your time. Anything from yourself, Manny?
No, that's good. Thank you very much, Stephen. Yeah,
okay.
If anybody has any questions, please feel free.
Yep, I think it's time to queue up my media, Damien.
I've got a couple of questions. We'll see if some others come through on the chat line. I guess I didn't get my grey hair from having an easy time in life. It was interesting, and I've had similar debates in the past without data, debates between a track owner and a rolling stock operator on what's causing poor ride. Is it the wagon or is it the track? Has this data being, or this, the ability to capture this data been able to be used to, for want of a better term, help the maturity of the relationships between track owners and above rail operators, so that rather than there be a problem and each one pointing fingers and having to go and prove it, it's actually built into access agreements that, hey, I've got this sort of rolling stock to get the best outcome for both the track and the ride quality. It needs this maintenance regime or something like that. Does that make sense?
Yeah, exactly. So this is one of the key points that we like. We like the system work together as a complex system and rolling stock. And I mean, I always tell everyone, if you have if you want to have a wonderful piece of track, you don't need trains, but that's defeating the point. So working together, that's quite important. And one of the key results that I presented, one of them here, that we have identified areas, for example, the track excites the train due to slight wear, and the infrastructure owners are actually looking into changing that part of the track. But again, the track takes longer time to be maintained or changed, but rolling stock can probably be a bit more flexible depending again on the route and the number of fleet. But how they can work together, for example, they can put in plan in terms of having changed the wheel profiles for a period of the time, and within that period they can plan maybe changing the track or the rail, or do other plan maintenance on the part of the track to fully remove that problem and make sure that the wear levels are lower and also everyone's happy. So both working together as we want to.
Okay. A question has come through on the chat line. Does the system offer functionality to create track quality index based on user specified parameters and their corresponding criticality levels?
So yes, that's one of the key points that we do. So we as Stephen also showed, we do analyze the data in a way that provides information the same as the track operators. So we provide the same vertical alignments as, for example, network rail measurement trains, and the accuracy of the system is good enough that they can make decisions based on the values that we get, which is similar to their values. And from there, you can say easily if it exceeds the thresholds of the standards, they can intervene, or they can put it into like monitor more closely. So we've got different, for example, we've got 4 levels of quality, and then it goes to one of those levels, and then it can be more triggered and more monitored for making sure that the track is degrading in the right term, or whether we need to maintain it sooner. So that's one of the key points. And yes, there is a minimum speed, because if your train's going too slowly, the sensors will drift and it can't provide enough information. And also wheel rate interaction is not the same, so the loading and the dynamic loading is not the same. So for that, we usually recommend anything above 15 km/h for having a good data set.
Another question I just thought of, and we'll get to the ones on the chat shortly. So my understanding in the UK, not so much like Australia, is access to the track for recording is very rare, as in, you know, traffic density is so great, it's hard to actually get on track to do track recording. So, you know, you're wanting to maintain to get the optimum cost, but you've also got very limited track windows to undertake track work. Is that another variable that's sort of fed into the box to determine best track maintenance regime?
So one of the things, we showed an example that if there is any maintenance regime happening, you to make the measurements using a loaded scenario, because if you do changes to track, you need to have a loaded track geometry information rather than unloaded one, especially when the train's going. So if your passenger train already has that equipment on, we can easily pass it through and see how the maintenance changed the track, and we can see all these degradation or changes so easily by day, and we can say how effective that maintenance was. However, sometimes when, for example, you tamp the ballast, it takes, for example, a week to settle, and we can easily see that settlement over a week as well by having the data. So we have done quite a lot of interesting work in network rail in Scotland, and we can see all these changes and how they can lift off the speed restriction just because we have the confidence in the data that are coming from the passenger trains.
Right, so you have your own track recording cars, or someone has track recording cars as well as a
No, we
equipment
don't.
fitted
So
to revenue trains? Okay.
no, so this is this system, this solution is the track recording basically. So we turned normal passenger trains into track recording vehicles basically by simple equipment, which is low cost inertial measurement systems, and basically fit and forget. You don't need even calibration on them.
Okay, so that might answer this next question. Track geometry data. Are geometry faults real time, so emergency faults can be notified live and attended promptly?
Yes. So this is the whole idea of this concept at the start. So the main key of these, the initial start of this sort of solution was the track geometry and understanding how the track degrades and how we can report that over real time, and making sure that the network can maintain those better in a more efficient way. And yes, in terms of track geometry, we can see all those very clearly day by day. So we've got at the moment over 10 fleets in the UK equipped with our system, and Network recently just changed the crossing and used our information to understand how the crossing change has changed the track geometry parameter.
Okay, this next one might have been written by someone from the track provider side. What is the strategy for finding the root cause if the issue is rolling stock wear related? But the question applies to the infrastructure as well. Do you just provide data and you get the two parties sort of fighting over whose data is right, or?
No. So this is a perfect question. I appreciate that sort of questions. So what we do is, for example, in a high-speed line, we have different type of classes running. So we have equipments on at least a couple of fleets of each classes, and two trains, for example, running on the same track. One of them suddenly say, "Oh, I've got something happening at this part of the track." So what we do is we look into the data. The data we provide is from axle box, bogie, and the body level, so we can actually see which part of the train is behaving erratically to cause that sort of action by the drivers or the fleet managers. And in one of the cases, for example, we get reports from this type of fleet, but then we look at the data from that fleet and from the other type of fleet, and we can see that data does not exist in the other type of fleet. So we can see the suspension or the wheel interface has got different sort of response, and that shows clearly that wheel of specific train or the bogie or the suspension of that specific train starts having some wear issues, and then we can identify those areas, which we have done that so far, and we managed to save quite a lot of delay minutes. So rather than to slow down the speed because of one train has reported it, they identified that was the train issue, so they took the train back to the depot, and they realized the wheels are actually not in the right place.
Okay. Couple more questions on the chat line. What proportion of the operating fleet is fitted with the equipment?
So depends on the operators and how they want to look into this, but we usually suggest minimum at least two same class have the equipment on one line. So if you have a line between, for example, Sydney to Melbourne, you've got two type of trains running, and you've got 30 trains of each type. We recommend minimum at least two of each train type.
And I guess any indication for the setup costs for this equipment?
So in terms of the equipment itself is, I mean, it's a four-figure number basically in the UK for us in terms of pounds, but that's just the hardware. The other cost would be engineering change that needs to happen, and installation and things like that. But in terms of data, we have some sort of a model depending on the operator, how many kilometer basically they do over, for example, 1 month, and depending on that, we can cost accordingly, because when you do more data collections, more data, then you need a larger storage, but also having a larger storage, having larger data bring the cost down in terms of that. So if, for example, let's say if you do 1,000 kilometers per month, maybe that costs us, for example, 10 to 15p per kilometer for the data analysis and for the data processes. But if you do 15,000 kilometers per month, that brings the cost hugely down per kilometers.
Okay.
It's fair to say it's a fraction of the cost of the proper system.
Yeah, I mean, in the end, we looking at very small amounts. I mean, the cost of a whole equipment is probably cheaper than the whole wheel set. So.
And do you think the industry has evolved to a point where it's almost mandatory to have this level of sophistication in order to satisfy rail safety accreditation legislative requirements?
But at the moment, there is no standard for this sort of equipment. So what we do is a complementary sort of assisting the system in terms of maintenance and identifying the root cause analysis. So this is more or less an analytical tool, but I can see this becoming a more of a norm for future, and we have been working with HS2 where they actually have required the in-service trains have the similar equipments on them. So that's becoming more like a standard. It's not standardized yet, but it's something that the industry is looking into, and in-service monitoring becoming more important, because what you're doing is you're measuring the track from the train that daily travels on it. So you have the same feeling, you have the right dynamic, rather than having a measurement train that has a different dynamic and doesn't have the frequency of operation. So in a way, it's a better sort of analysis in the end, and seeing how these wheel and rail are interacting together, and finally making sure that the train's performing correctly, and also tracking is in the right place.
Does this type of system have any major blind spots compared to other systems of track measurement?
So we don't measure gauge because we don't have lasers, and that's what one of the reasons that we are cheap and easy to fit and easy to comply is because of not having the lasers. So one of the key points is that. But if there is any gauge issues, we will see that problem in the wheel rail interface, and we can see that, for example, in certain areas the bogie starts hunting, so we can see those issues, or the wheel set starts having some lateral movements, which again we see those. So there are some limitations in terms of exactly comparing to norms, but we have other ways of identifying those issues. So it might not give you the exact index value as the standard says. For example, it doesn't tell you the 1400 millimeter gauge, but it does tell you there is something at this point is wrong, which then you can look into the gauge recordings from the track measurement trains, which is every maybe 2 months. You can actually see there is a problem with the gauge there.
All right. Can the system be connected to a mobile device while doing front of train inspections, or can it only be sort of analysed back in the office?
So everything at the moment gets transmitted by 4G network to the cloud. So everything goes directly to the cloud. Every minute goes to the cloud, and how we do is we calculate the journey to journey basically. So if the train starts from this point and stop at the second point, so A to B, then we start running basically forward and backward filters to provide the track geometry for that specific track. So that could be I mean, we could provide that in real time, but we prefer that to the journey to ends, because then we can actually come back and do a backwards filter to make more accurate data and information. In terms of seeing the data live, we have demonstrated that the raw data become live, so that the users can see the raw data, but I don't think that that's providing much information, especially when you're going on a train at 100 kilometers an hour and suddenly you see a bump. What are you going to do? We're going to brake and stop and go and have a look. It's just something that it's not been wanted, I mean, by any of our customers, but again, it's a software thing that we can easily develop. That's not a difficult thing.
And I guess, is there a sort of order of magnitude cost benefit of this approach versus how track maintenance has traditionally been done?
So one of the key points is we've seen a huge sort of benefit in the UK is to first of all, to identify what is the issue. Is it a train or track issue? Because if the train operators report something and they put speed restrictions, then those delay minutes is cost. So we have delay minutes in the UK that can start from hundreds per minute to 3,000 per minute. And these costs are huge. And if you can identify these issues and making sure those delay minutes not happening, then as I showed, one of the issues, but Network had about 100 delay minutes reported and cost them about £7 million. Imagine if 10% of that even is already paid off for the 10 years of this equipment's been used. So again, it's one of those areas, and we have identified issues, for example, with certain rolling stock, with certain wheel profile, with certain body suspensions. We have identified areas of track that the geometry in a way is exciting the train suspension again, and we are working with the train manufacturers in terms of how we can compensate those manufacturing design issues. I mean, sometimes it's not just track, it's the manufacturing design issues, which we have seen quite a lot on reset trains, because everything's done by computer models, and the error margins are usually low because of the cost saving and making sure everything's made effectively in a cheaper way. And then that's again adding another issue, because the track doesn't always behave as what we have in the papers and in the equations. Sometimes the complex issues can bring more strain on the trains and causing different type of damage to the train itself.
Okay. Is the system independent of the rolling stock, power supply and comm system?
So we don't need comm system from the rolling stock. We do want to have power from the rolling stock. The system does not consume much power, it's only 5 watts. So in the grand schemes of power, is probably less than a mobile phone in terms of how much is using energy. And we have run, in certain cases, we have had freight trains that we work with and they don't have power, for example, on the train. So we have run them on batteries, and the batteries, depending on the type of battery we use, can last up to about maybe 10 days. And every time the train goes back to the depot, they're replacing the batteries or charging it, depending on what the solution they want to have. So, and there's also axle box generators that can be procured from third parties that can run our equipment easily.
Okay. And I think this might be the last one. What are the commercial arrangements, costs for the use of the cloud software, and where does the recorded data sit?
So at the moment, depends on the customer. So we can direct the data to go into the customer's cloud storage. We are basically software agnostics. For example, one of the customers at the moment we're working in, everything's been stored on their Azure database, the data stores. We've got our own Azure data stores as well, so everything goes to that data store and then starts getting processed as soon as it reaches the servers. But for the processing, we usually use our own basically servers, and all cloud systems that we have is basically a bunch of remote servers that we can link the data to, and then sends the data back into the places that you want. So one of the examples that we've shown, that we're working with Deutsche Bahn and InfoView, which that are the data part of Deutsche Bahn. And what happens is the data comes to our servers, we process it and we send the results to their servers, and then they just take control of the visualizations and how they want to show it to the track engineers, because that's how they want it to happen. So we have those APIs set up that everyone can access the data in a way that they want, or they can simply use what we can provide.
Okay, thank you. Well, that's the last question. I've got to say, there's no shortage of data around in this world, particularly in railways, but this is another great example where you're turning lots of that enormous amounts of data into useful information that can be used for commercial engineering purposes. So look, fascinating topic and presentation. Thank you so much, Stephen and Manny. Thank you for getting up early, Manny.
Well, thank you for having us. That has been fantastic. Thank you.
Thank you for having us.
Thank you. And just a reminder for those still on, the next webinar is actually next Tuesday between midday and 1 p.m. And the title is Managing Occupational Violence and Antisocial Behaviour in Rail. So another great topic. Thanks everyone for attending. Again, thanks Stephen and Manny, and enjoy the rest of your day.
Okay, thank you.
Bye.
Bye.
Thank you.